Okay, well, everyone is already quiet, but welcome to week 6. Here's the attendance form, but I'll come back to it if you haven't done it yet. Yeah, the votes. So I said choose a number from 1 through 10, because why not? No one chose 9, and the cool thing is, everyone guessed that no one would choose 9, so or the majority. And this is percentage, not number of people. So I found that really interesting. I don't know. There was this Veritasium, this YouTube channel that did something similar. I thought 3 and 7 would be the highest. 7 was the highest, but yeah, I didn't expect no one choosing 9. That got me off guard. But yeah, that was cool to see. But yeah, this week, as I mentioned, we're not assigning anything. We're not doing RL. But if you're caught up on everything and you are interested, feel free to look at the unit. It's like on the Mega Doc, Unit 6. I think it's cool stuff. I remember thinking Q learning was pretty fun when I learned it. But if you're not caught up with all this stuff, like this would be a great week to catch up on everything. And then by next week, let's see, there will be like 3 more till the end. So then I think based on next week, we'll determine like who's like even far enough to potentially get a certificate. So yeah, please just like catch up if you are interested in that. We'll be checking for it coming forward. So use this week as a break, but also to catch up and enjoy the sun, of course. And then please ask questions and like just send whatever. Honestly, like maybe I should just send a meme right now, because like where's my cursor? It's quite dead in there. Yeah, I'm gonna send a meme. Because it really is dead. Yeah. Also ask questions there though if you're interested, or your group chats. Yeah.
I'm all set up. Okay. I guess I'll introduce myself first. I'm Madeline. I'm a second year studying computer science. I've been working with the AI Alignment Club at UW for a little over a year now, and I've just this quarter been starting to do a little bit of work within I2 as well. So I wanted to give this talk to just introduce you all to AI safety, what it is, why it's important, and how you can potentially do some work within the field. Personally, I think it's a very interesting and nuanced field, so I suggest you guys check it out. I also kind of want to start with like a disclaimer about myself. Like, I don't want to position myself as like an expert on AI safety or anything. I just personally find it interesting, and I hope you guys can kind of look into this discussion around it as well. Okay, so I will kind of start off by talking about current large language models, as I'm sure you guys are familiar with, maybe with ChatGPT as a nice example. So we know ChatGPT is very highly capable at a large variety of tasks. It's great at completions, answering questions, things like that. And so when it was first released and as it continued to improve, there's a lot of excitement around it. So, like we can see here in this kind of nice example, this user is making this request, find citations from journals about this topic, and then it gives this very nicely formatted and detailed analysis of all of these sources here. But of course, with additional usage, people started to realize that ChatGPT actually has some pretty serious flaws. For example, it actually turns out that if you ask for these citations here, all of these sources are actually fake. So none of these are real. And if you prompt it for more real answers, it's still just going to give you, fake citations. So this is a problem with ChatGPT and a lot of other large language models. So what's the problem here? Well, first of all, it looks pretty convincing, right? So if you're looking at this and you have no idea, about whether these sources are real or not, you'd probably say, okay, yeah, these are real. And, if you wanted to fact check it, you could. But for tasks that are harder to fact check and harder to realize that, maybe the information you're getting is inaccurate, then this becomes sort of a problem. Okay, so let's see. Yeah, it turns out that GPT-4, along with many LLMs, have issues like this. So like we just saw, they can hallucinate, but also they are very confident in their answers. which can be problematic when it turns out that they're actually wrong. So unless you personally can catch this, then, you're kind of stuck there, right? Okay. So what we kind of have been observing throughout deployment of more and more generative models is that they can demonstrate really unexpected behavior in lots of different ways. This is maybe another example where they struggle with something called the pink elephant problem, where if you tell them not to include something in their generation, they will actually include it. It will be more likely to include it. And so these are just a few examples of here. There are a couple more, like sycophancy, basically just is where the model tends to produce answers that tend to flatter their users' stated beliefs. Sandbagging is also where language models will tend to parrot common misconceptions when it takes note that the user seems less educated. And so, again, this is far from an exhaustive list, but this should give you sort of an idea of where we're at with the most capable models we have today. So what's troubling to me here is that the majority of these weird behaviors are not caught during the testing phases of these models. We only start to discover them after they're already out in the wild and people are using them for, important tasks. Okay, but what's the problem here? Everything, has bugs and problems at some point. Why don't we just fix them? But the problem here is that dealing with these issues has proven to be quite hard. So these problems are a consequence of kind of how these models were trained. And so their existence within these models is sort of intrinsic. It's hard to sort of patch them out. So for example, with the hallucination problem, decoder-only LLMs like GPT really by design just predict the most probable word just from their training distribution. So, they're producing words that seem the most likely to look right. But in other words, they're actually not optimizing for truth or accuracy. They're just optimizing for the highest probability that it showed up on the data it was trained on, generally speaking. So when it comes to unlearning this is actually very hard because this is just how these models are inherently built. So I want to put a lot of emphasis on this. They're not optimizing for what we think they're optimizing for. It's kind of a proxy for good behavior, but it's not perfect. Okay, so of course, developers and researchers are trying to make these models safer, but these fixes are unfortunately far from robust. So a few weeks ago at the ML security workshop, we had this kind of activity where we had people, trying to jailbreak ChatGPT and get it to produce, forbidden generations. And, it's not really difficult to do so. We were able to kind of just play around with the prompts a little bit and get it to do something that it's not supposed to. So really these fixes are far from robust. Okay, so as it stands, we actually have no reliable techniques for robustly steering language model behaviors. So we actually have no way to be sure that the AI systems we're developing will remain in line with our goals and intentions in every situation. So techniques being used up to this point to kind of correct model behavior like prompt engineering, supervised fine-tuning, and reinforcement learning don't quite cut it. They don't really exhaust every plausible situation a model might encounter. And so it's precisely in unseen scenarios that these models behave kind of unpredictably. And so coming up with methods to prevent undesirable behaviors is really far from trivial. And some of this hardness is not unique to transformer models, but just lots of AI models in general, with how we come up with optimization functions and things like that. Additionally, experts in AI still struggle to interpret deep model internals, meaning that if we think of neural network architectures as loosely modeled after the human brain, our tools for doing neuroscience on these models is very, in a baby-like state. And so intuitively, we want to be able to really mechanistically understand how models arrive at their outputs so we can figure out where our problem's coming from. How can we fix them? But as it stands right now, we have no idea. And so finally, AI systems will only continue to grow in scale. They're going to grow in scale, they're going to grow in capability, and they're going to grow in impact. We're pouring billions and billions of dollars into AI development. So if we cannot be absolutely certain that the systems we're going to be deploying are absolutely safe, what will that look like, right? So we ideally want to be able to control and rely on the most impactful systems in the future. Okay, so I mentioned this on kind of that last point to touch on how these powerful systems might manifest. So I can't really talk about AI safety without mentioning AGI, but you might have heard the term before. It's been sort of flying around. AGI stands for Artificial General Intelligence. Artificially intelligent systems that can perform as well as or better than skilled humans at a wide variety of tasks. So like I said, we're pouring money into AI. And the largest players in technology are really racing with each other to produce the next best AI system. And so whether these efforts will result in AGI is kind of a topic of a lot of debate. But we can make some guesses. Up here we have sort of some predicted expectations for when AGI might come about from a couple of experts surveyed at a conference. And so we see a lot of different estimates, but generally speaking, AI experts, around half of them expect to see it before 2061. So this is kind of well within our lifetimes. Also, OpenAI, for one, also states that their mission is to develop, quote, safe AGI. So people are actively working towards this. And so the reason I mention this isn't to convince you that the end of the world is coming and that AGI is nigh, but I believe the discussion around AI safety becomes, and why it's important becomes a lot more clear when we're talking about AI that approaches the level of powerful capability we're talking about when we're talking about AGI. And so the point here is that it seems likely at this point that very powerful systems are coming sooner rather than later. And so when these systems come about, it should make sense that we want to be able to robustly control them and also be confident that they're not going to explode on deployment, like we've seen with some other AI models. This is Microsoft Bing Chat, which you might remember coming out in early 2023. It released and then it promptly kind of went crazy and exhibited really bizarre, concerning behavior like we see up here. So, when it's something like a chatbot, weird behaviors like this aren't going to have that much impact. But, as we deploy AI in more high-impact scenarios, we don't want to learn where it fails the hard way like this. Okay, so I think at this point I should clearly define AI safety. So fundamentally, I define AI safety as the field exploring robust techniques for keeping AI systems aligned with human goals and preventing risks associated with AI, both accidental and resulting from misuse. So hopefully I made a decent case up to this point about why this is something we should care about. And hopefully you have a sense by now too that AI safety should not necessarily just be an afterthought to developing AI systems. Rather, this should be a non-negotiable in every step of the AI development process. We want to focus on it first so we don't have to clean up any messes later. And as we discover, cleaning up those messes can be extremely hard. So I also want to note that during this talk, I'm kind of primarily focusing on, failings with the models themselves. But there are lots of other ways that AI can cause harm besides being just flawed and buggy in themselves. They can be misused in a lot of different ways as well. Okay, so like I said before, making AI systems safe is pretty hard. Not necessarily hard in the intractable sense, but it's hard in the very difficult sense. But developing AI is also hard. So that shouldn't stop us from trying to invest into this area. In fact, it should be the reason we invest even more effort into it. If we want to make these systems safe, we'll need to dedicate time and effort and talent into, broadly these following things. First, discovering where models fail, discovering how to control them, and discovering how to understand them. So I think these categories are, definitely very broad and maybe a little bit reductive, but I think they're good starting goalposts for, approaching safety. So on that note, I want to just briefly talk about a couple of different areas of research that seek to give us answers in these different aspects. Okay, so first up is AI red teaming. I sort of broadly define this as using AIs to make other AIs safe. So there are a lot of different interesting techniques under investigation within this area. So the first being scalable oversight, which explores how to use AI models to supervise other AI models and ensure that they remain aligned with what we want. And so this is helpful because human supervision can be expensive and sometimes a little bit unreliable. And so this can provide an avenue for continuing to supervise AI systems, even as they, evolve behaviors that are too complicated for us to understand. So within this area of research, we have the weak to strong generalization problem. There's also this paper called Constitutional AI. It's pretty interesting. I recommend checking it out. Basically, it uses another AI system to fine-tune a language model to be in line with a constitution of like good rules and tasks. It generally performs pretty well on like harmlessness benchmarks, which is cool. Yeah. And researchers have also been employing AI red teams to find weaknesses in AI models and domains where they fail. So again, being able to automate this red teaming process is really helpful because we can kind of cover a lot more ground this way and figure out where are our weaknesses in our current models. There's also AI safety via debate, which kind of pits two AI models against each other to determine like which model is telling the truth. So kind of different areas of research here. Next up, the area that broadly seeks to understand model internals is usually called mechanistic interpretability. So here we want to figure out the role that certain neurons or circuits within neural networks have in producing model output. So as you might expect, this is one of the most rigorous areas of research, but also the most difficult. Trying to understand individual neurons within a human brain is similarly very difficult. And so, there are many different approaches to understanding model internals and understanding them better, not necessarily all down to the neuron level. And so, many researchers beyond just safety researchers are working on this as well. But most of the research I listed here looks at neural networks on a very fine-grained level. Like here in this paper, they use something called a sparse autoencoder to sort of figure out when certain neurons fire in what context. So like they'll discover that like a certain neuron fires when it hears the word water or something like that. So kind of cool properties being kind of discovered here. On a higher level, we have transparency, which is also seeking to understand models, but on a less fine-grained kind of scale. I'm personally the most optimistic about this. I think it's really cool. So, that being said, I wouldn't call it like super strictly separate from the other category I mentioned, but yeah. So we have this paper here, Representation Engineering, super cool paper that sort of is able to extract representations of concepts within a neural network. So, what's a model's representation internally of truth or certain biases or something like that. It can also help with detecting when models hallucinate, which is pretty neat as well. Eliciting latent knowledge is another area of research that also just seeks to discover and interpret latent representations of truthfulness in model internals. Okay. And so you'll note that I spent the majority of this talk discussing technical shortcomings of models and technical research, but this is far from the only area that is important for AI safety. So being able to regulate and develop policy around AIs is also very important, just to ensure that they're not misused in any way. And so this is absolutely essential for preventing AI risk in the future as well. So these kind of risks here described are from the Center of AI Safety, sort of broadly categorizing different ways that AIs can pose risk to people. And a lot of these do definitely involve, properly developing policy around AI. Okay. So as for how you can contribute to this field, there are a lot of different ways. Generally speaking, I think it's most important to figure out what is interesting and important to you. If anything that I mentioned in this talk seemed pretty cool, seems like something you want to learn more about, I would definitely start there. Look for where you can learn more about whatever you're interested in, and then from there figure out, what is important in this area, what are people currently working on? What are some existing questions within this area? And what do I need to know to be able to contribute to this area? And from there, that should give you a solid direction for how you can contribute to this field. AI safety research is very open, so if you find anything interesting, it's really simple to just reach out to whoever is in charge of the research and talk to them about it. And you can really learn a lot from doing this. Okay. As for where you can learn more about different interesting areas of work, there's a number of places doing research in AI safety. I listed some of them here. Eleuther AI actually has a Discord channel with all sorts of people doing different projects, lots of discussion around different kinds of paper in the AI safety realm, but also in the realm of overall ML. So really great source for just sort of recent papers going on in there. And yeah, this link just has like an overwhelming amount of sources. But yeah, if you happen to be interested in any of the technical research we discussed today, you might be glad to hear that we are hosting an AI safety reading group next week on Wednesday. It'll be at 5 p.m. in Savory 137. Yeah, so we're just going to talk about cool papers together, and it'll be a good time. So we'll share more information about this in the next couple of days. But if you found any of the papers I mentioned today even a little bit intriguing, let me know, and we can consider talking about them in more depth in our meeting then. Okay, well, thank you for listening to my spiel. I really appreciate your guys' attention. If you have any questions, go ahead and ask me now, or you can email me later. I'll be around. And yeah, thank you guys.